Yeah, welcome to Relative class. This is physics class. We're talking about frictional force, where emphasis will be laid on coefficient of friction. Before that, let's look at the objectives of the lesson. By the end of the lesson, the students will be able to define what the frictional force and explain the coefficient of friction and solve some problem related to frictional force. Now, let's begin. Now, what is frictional force? We have so many types of forces: magnetic force, electric force, nuclear forces, and nuclear magnet. They're all there. Now, frictional force is also a type of force that existed when two objects are wrapped or relative motion of two objects are wrapped between each other. For example, these are two objects are rabbit. Obviously, friction exists between two objects, the surfaces. If I wrap my hands together, friction exists between it. If I wrap any two objects together, friction exists. Therefore, frictional force is defined as a force that exists when two objects are wrapped between each other, or relative motion between two objects wrapped against each other. So that is frictional force. Let's go to what is coefficient of friction. Now, under frictional force, we have what is called, we have dynamic friction and static, dynamic friction and static friction. This talk about relative motion of two objects. Dynamic friction is when two objects rub against each other and they are all in motion. Static friction is two objects rub, one object stable, static, while the other object rub against each other. When these two surfaces are rubbed against each other, there is what we call the coefficient of friction. The magnitude of this frictional force that exists between these surfaces, we call it what? Coefficient of friction. The measure of the value or the degree of the frictional force. For instance, if I rub these two surfaces together, the frictional force here is different from when objects are rough. The surface here is rough, another rough surfaces. When rub them together, you can say that the friction that exists here is different from this place. That is so we use the term mu as a sign of coefficient of friction. Now, coefficient of friction depends on two surfaces in contact, and also coefficient of friction depends on a given as force times the normal reaction. Now, the coefficient of friction can cancel the force over what? The normal reaction, where this one is force, this is what? Reaction force. If this is an object placed on a horizontal floor surface, obviously in a rough surface, and this object has been pulled with a force forward, what happened? Frictional forces exist here. The object has a reaction R, which is equal to the weight of the object. So R here is equal to the weight, which is mass times gravity. So we can say that force over what? Mg. So the coefficient of friction, this unit is in unit newtons. The coefficient of friction has no units. It has no units because the two forces cancel out. Let's solve some question regarding to this. What is the magnitude of coefficient of friction when a force of 200 newtons pull an object of mass, this, on a rough horizontal surface? Now, imagine the surface is rough surface. The mass of the object is 80 kilograms, and a force of 200 Newton pull against it. What is the coefficient of friction here? So we know that force is given by this. So we can say that 200 divided by 80 times 10, because G is 10. So the coefficient of friction here is given as what? 0.3. This is the value of the magnitude of the frictional force that existed between this object and the surface. Therefore, we touch on today we add the definition, we explain the coefficient of friction, we saw a program related to the frictional force. In this note, we call it a day. Thank you so much for my class, and God bless you. If you have no question, tap down, ask more questions. Thank you so much.